Wow, it's hazy today. What is all that stuff in the sky?
Hi, I'm Juliane Fry. I'm an atmospheric chemist at Reed College in Portland, Oregon. With support from the Dreyfus Foundation, my students and I work to understand the chemical mechanisms that produce airborne particulate matter, which is the smog or haze that reduces visibility and can aggravate your breathing. Our hope is that by the detailed knowledge of the chemical mechanisms that produce this haze will enable policymakers to make more informed decisions about regulatory policy that can give us all cleaner air to breathe. This is one of the tools that we use for our field measurements. With this particulate matter sampler, we can collect particulate matter from the air and concentrate it onto these filters. And then we take the filters back to the lab and we can analyze them chemically to get clues about the different sources of haze and particulate matter in the atmosphere. So for example, if we measure organic nitrates on these filters, that gives us an indication that the source of the particulate matter could be from NOx, from tailpipes, from vehicles. But particulate matter can come from a variety of different sources. For example, right now, mid-August 2018 in Portland, Oregon, there's a lot of haze in the atmosphere that's coming from forest fires, which are currently burning from California through Oregon and Washington up to British Columbia. If we collected this particulate matter, it would be characterized by elevated concentrations of potassium and levoglucosan. So using molecular markers like these, we can collect particulate matter somewhere and partition it out and determine what fraction of the particulate matter comes from these different sources, like vehicle emissions or smoke. We can do this kind of collection and analysis either at a fixed sampling location, where we measure over a period of time and look at how the sources evolve, or we can even do mobile monitoring. Here we are at Forschungszentrum Jülich in Germany, where we're running a series of experiments in this atmospheric simulation chamber, SAPHIR, a 300 cubic meter chamber where we can simulate atmospheric processes. So this month we are running a series of experiments adding nitrate radical, which is again formed from NOx emissions from tailpipes, to naturally emitted isoprene, which is a organic molecule that's emitted by trees like these. So in these chamber experiments, we can control the ratio of the different molecules present, which determines which of many potential chemical pathways the reaction proceeds along. And then we can check how much particulate matter or aerosol is produced under each different condition. By comparing these experiments to what we measure in the ambient atmosphere, then we can gain a more complete understanding of mechanisms of aerosol formation in the atmosphere and how human activity influences them.